Consider this simple fact. One hamburger patty, it can take over 600 gallons of water to produce. That's a lot of water. More than many people drink in 2 years. This hidden cost of meat is staggering. It makes us think about our food. A new idea is emerging. It's called lab-grown meat, or cultured meat, or cellular meat. This is meat made without traditional farms. It doesn't come from a slaughtered animal. Instead, it grows from animal cells. These cells are nurtured in a clean facility. This could truly change our food system. Scientists take a small sample of cells. These cells come from a living animal. No harm is done to the animal. The cells are then fed nutrients. They grow and multiply in large tanks. Let's look closer at how this meat is made. The journey begins with cells. These are often muscle cells or stem cells. Stem cells are special. They can become different types of cells, like muscle or fat. These cells are the seeds of the future meat, carefully selected, carefully stored. These cells need food to grow. This food is called a growth medium. It's a rich broth of vitamins and proteins. It gives the cells everything they need. Finding the right affordable medium is key. Early versions used animal serum, but the goal is an animal-free process. Plant-based mediums are the future here. Meat is more than just loose cells. It has structure, it has texture. To create this, scientists use scaffolding. Think of it like a mold or a frame. The environmental case for lab-grown meat is strong. Conventional livestock farming is a heavy burden. It produces a lot of greenhouse gases. Methane from cows is a big problem. Nitrous oxide from fertilizers is another. Cultured meat production aims to slash these emissions. By growing meat directly, we bypass much of the impact. This could be a vital tool against climate change. Think about the land used for livestock. Vast areas are cleared for grazing. More land is used to grow animal feed. This means less land for forests, less land for natural habitats. Lab-grown meat needs far less land, perhaps up to 99% less, some studies suggest. This could free up land for rewilding and recovery. Water usage is another major concern. Traditional meat production is very thirsty. Animals drink water. Crops for feed need irrigation. Cleaning facilities uses water too. The first lab-grown burger was unveiled in 2013. It was a momentous occasion marking the dawn of a new era in food science. It cost a fortune to make, with the price tag reaching hundreds of thousands of dollars. Reports on its taste were mixed, with some praising its potential while others were less impressed. Some found it dry, lacking in fat, and not quite like the real thing. This was a pioneering step, but clearly just the start of a long journey. The challenge was clear: make it delicious, make it appealing, make it indistinguishable from the real thing so that even the most discerning palate can't tell the difference. Taste and texture are paramount for consumers, who expect nothing less than perfection. Scientists are now food artists in a way, blending science and culinary arts. They are learning to recreate meat's complexity down to the finest details. Meat is not just protein. It's a symphony of muscle, fat, and connective tissue. It's a matrix of muscle, fat, and connective tissue, each part contributing to the overall experience. Each part contributes to flavor and mouthfeel, creating a unique culinary experience. Researchers are culturing fat cells alongside muscle cells, aiming for that perfect balance. This adds juiciness and crucial flavor compounds, making the meat more palatable. The science of deliciousness is advancing rapidly, with new breakthroughs happening every day. The quest is to mimic familiar cuts, from steaks to chicken breasts. Ground meat was the first success, paving the way for more complex creations. Burgers, sausages, and nuggets are easier to replicate. But what about a steak or a chicken breast? These are the real challenges. These require more complex structures, intricate and precise. Edible scaffolding helps create these textures, bringing us closer to the real thing. Section 5. Empty fields, full stomachs, securing food in a shifting world. Our global food system faces huge challenges. The world population is growing steadily. We will need to feed nearly 10 billion people by 2050. Climate change makes farming harder. Droughts, floods, and extreme weather are more common. Traditional agriculture is vulnerable. We need new ways to ensure food security, ways that are resilient and sustainable. Lab-grown food offers a promising solution. It can provide a stable source of protein. Production is not dependent on weather. It is not vulnerable to animal diseases. Diseases like avian flu or swine fever can devastate livestock. Cultured meat facilities are controlled environments. They can be built where people live, reducing reliance on long, complex supply chains. Another innovation is vertical farming. This means growing crops indoors in stacked layers. Think of skyscrapers, but for plants, LED lights replace sunlight. Section 6. The Thinking Farm Bites and Botany for a Bountiful Harvest. Beyond labs and vertical towers, traditional farms are also changing. Precision agriculture is transforming how we grow food. It uses technology to make farming smarter, more efficient, and more sustainable. It is about giving crops exactly what they need. No more, no less. This approach helps farmers do more with less, protecting resources for the future. The tools of precision farming are diverse. Drones fly over fields, collecting data. Sensors in the soil measure moisture and nutrients. GPS technology guides tractors with incredible accuracy. Automated systems can apply water or fertilizer, only where it is needed in the right amounts. Farmers use software to analyze all this information, making informed decisions based on real-time data. These data-driven insights are powerful. Farmers can identify problems early, like pests, diseases, or nutrient deficiencies. They can optimize their use of resources. Section 7. The Journey of Sustenance, Keeping Food Fresh, Fair, and Forward. A lot of food is lost before it reaches our plates, leading to significant waste. Spoilage is a massive global problem that affects every corner of the world. Estimates suggest up to 1/3 of all food produced is wasted, a staggering amount. This happens at every stage of the food supply chain. From the farm, during transport, in stores, and even in our homes, food is lost. This waste has huge economic and environmental costs, impacting our planet and wallets. Reducing it is crucial for food security and ensuring everyone has enough to eat, and for a more sustainable food system that can support future generations. New food preservation techniques are emerging, offering promising solutions. They go beyond traditional methods like canning or freezing, providing more options. High-pressure processing can extend shelf life significantly. It does so without high heat, preserving nutrients and maintaining food quality. Natural antimicrobials derived from plants can prevent spoilage effectively. Edible coatings can protect fruits and vegetables, extending their freshness. These innovations help keep food fresh longer, reducing waste, reducing the need for artificial preservatives and chemicals. Smart packaging is another exciting area of development. Packaging can do more than just contain food. It can enhance its longevity. It can actively monitor freshness, ensuring quality. Some packages even change color if food is spoiling, providing a clear indicator. Section 8. Your Fork in the Road. Choices for a Conscious Food Future. The future of food is not just about technology, it's about the choices we make every day. It is also about us, the consumers. Our decisions have a profound impact on the food system. Our awareness and choices shape the food system. By being informed, we can drive change. Understanding these new foods is important. We need to know what we're putting into our bodies. Learning about lab-grown meat or vertical farms can help us make better choices. Knowing how precision agriculture works is crucial. It can lead to more sustainable farming practices. This knowledge empowers us to make informed decisions. Decisions that can benefit our health and the planet. Decisions that align with our values. Ethical considerations are a key part of this. Ethical considerations go beyond animal welfare. They include the impact on the environment and society. We must think about access and equity. Ensuring everyone has access to healthy food is essential. Will these new technologies benefit everyone? Or will they widen the gap between different communities? Or will they create new divides? It's a question we need to address. Who controls these new food production methods? The power dynamics in the food industry are shifting. These are important questions to discuss. Open dialogue is necessary for a fair food future. Ensuring a fair and just food future is vital. Everyone should have a seat at the table. Sustainability must include social sustainability too. It's not just about the environment. Future trends point towards even more personalization, tailoring food to individual needs. Imagine nutrition tailored to your specific needs. Personalized diets could become the norm based on your genetics or lifestyle. This could revolutionize how we eat. Artificial intelligence will play a big role, from designing new foods to optimizing supply chains. AI can make the food system more efficient. Sustainability will continue to be a major driver. Consumers are increasingly demanding food that is good for them. Consumers are increasingly demanding food that is good for them and good for the planet.